Hey students, so the question is from one of our questions that we have in our packet is taking a look at this shape right here. Will we actually ever see the triangle, the circle, and the star in the same position in this hexagon? One of the things and I want you guys to some of the clues in which are given for this is that the rotation of some of these items. For the circle is actually going to the circle is actually going to move 3 clockwise. The star is actually going to move 1 degree, one movement counterclockwise, and the triangle is actually going to move 4 spots counterclockwise. And so when we're taking a look at this pattern right here, the question is, well, will we ever see these shapes at the same position again if we were to keep on turning it? Alright, so basically what that means is that, let's say for example we have a circle that's going counterclockwise, three spots counterclockwise. That means that we would go on 1, 2, 3. So we would see that circle right there. If the star is moving 1 degree counterclockwise, we would see the star going 1 degree going this way. So that means that the star would be over here. So even at the next turn, we would probably see the circle over here, and we would see the star over here, and then over here with the 4 counterclockwise for the triangle, that means we would have it at 1, 2, 3, 4, in which that they would all kind of align over here to the right hand side. So the question would be, will we ever see these shapes at the same position as they are right now? Some of the questions that we have to ask ourselves are, well, what patterns do we see within this process? Well, first one, we know that the star is a really easy pattern. We know that the star is just going to move 1. The next thing we get to ask ourselves, what does really the circle do? Really kind of study the circle. And the third one is, the triangle is the most difficult to predict, and can we actually start predicting it to be able to see how it's going to move? So let's take a look at the first one. This is the circle. We all know that every time that a circle is actually going to move, we know that it jumps from one side to the next. So if this is the original position, on the first turn it goes here, and then on the second turn it goes right back here, because it's moving 3 spots counterclockwise every time. So we know that it's flipping back and forth. So we know that if I'm looking for turn number 4, right? For turn number 4, we know that all the even turns would keep the circle over here to the left. So keep that in mind as we're actually turning the piece. Is that if we want to make sure that that the turns are even, that means the circle will be back to its original position. So that's really important. So let's take a look at our next one. The star. Well, the star is really simple too. This is the fact that we know that the star is going to be moving from one spot to another in regards to just its original position and moving counterclockwise. So actually I did this wrong. The star was actually supposed to be moving counterclockwise. So if this is the original position for the star, that means that this one right here would be point 1 or star 1. And then star 2, position 2, then position 3, then position 4, then position 5. And then right back here at position 6. So we know that every time that I want to move, if I want to move this star back to its original position, it would actually have to be 6 to be able to move it back to its original position. So right now, as you're thinking about this, okay, so 6 may be a good idea for us to be able to keep in mind in regards to getting everything back to its normal position. So now let's take a look at the triangle, the most difficult one. If we take a look at all these different shapes and things like that, we got to think about, okay, well, here's a triangle, right? So the triangle's here, and it moves 4 spaces 4 spaces clockwise. So 1, 2, 3. 1, 2, 3, 4. So it end up being over here for the first turn. Okay, for the second turn, it will end up being 1, 2, 3, 4. So it end up being over here. So the question at the end of the day is, if I want to can these shapes go back to normal in its original position, and actually how many turns will it take it to actually make it to its original position? So what do you think? How many turns do you think it will take to get it to the original position, or will it ever go back to its original position? All right, so comment here below and let me know what you think, and then give me some use examples from this video and also from the text to back up your claim. All right, guys, good luck.